Okay, so let us start with the first question. It says that five identical spheres are placed between two blocks in order to measure their diameter. If you can see, there are one, two, three, four, five spheres are placed between the main scale, in on a main scale between the two blocks, right? And now what has been asked, what is the diameter of a single sphere? You need to find diameter of a single sphere. For that, what you have to see, if you will see, it's from 5 to 16 centimeter. So let us see, the spheres are placed between how many centimeters. So for that you need to just subtract 16 minus 5, so you will get 11. So these five spheres are placed between 11 centimeter. Now you have to find out diameter of a single sphere. To find out diameter of a single sphere, just divide 11 by 5 and you will get 2.2 centimeter. So answer for the first one is A. Second question. Okay, so now let's see second question. It says that a student wants to take a particularly accurate measurement of volume of liquid in a measuring cylinder. Which of the following procedure will make her measurement less accurate? Now here you the question is been asked that what she will do so that her measurement is less accurate. The very first option that is given is putting her eyes level with the height of the measuring cylinder, measuring to be taken. So yeah, this is correct. If you want to take it is if you want to take measurement from the measuring cylinder, which is like something like this. Okay, so there is two meniscus, lower one and upper one, and you have to keep your eye at a particular height of it to get the exact reading. If you will look below or above, if you will look below the meniscus or above the meniscus, you will not get the exact reading. It should be from the height. You should see from the same height. The first one is correct. Second says that the reading of the liquid level from the bottom of the meniscus. Yes, whenever we take reading of a liquid, there are two meniscus for the liquid, the upper one and the lower one. So we always take bottom, we always take lower meniscus for the reading. So whatever reading is here, it says, let's say if it is 5 and this is 0.5 5.1, so you're going to take 5. So this one is also correct. Using the largest measuring cylinder she could find. Yes, so if she will use measuring cylinder which is, let's say, wide, which is very large, so what happened, the height difference will be very low. If you take a measuring cylinder with the large cylinder, so the height difference will be very low, and height, to find out height difference low, the accuracy reduces. So if to get the answer more accurate, we take the narrow one so that the height difference is very sharp and we can able to take it, right? So this one, yes, the from doing this one she can get a less accurate answer. Let's see the third one also. Using a set square to make sure the cylinder is perfectly vertical. Yes, you should keep the height of a cylinder like very much perpendicular from the floor, so to get the exact reading. So this one is also correct. So if she wants the measurement should be less accurate, she has to take measuring cylinder or largest measuring cylinder. Okay. Okay, now look at the third question. It says a student is timing the rate of cooling of a beaker of water. On a repeat run of investigation, the student forgets to zero the stopwatch. Okay, so this one is not starting from zero, starting from, let's say, 11 minute. Okay, the reading of the stopwatch at the start time and the end time is shown into the figure. Calculate how long it took the beaker to cool. So you need to find out the exact time that is taken by the beaker to cool down the liquid in it, which is water in it. But the question is, the stopwatch is not, the starting time of the stopwatch is not 0, it's 11 minute and 19 second, and it's end at 23 minutes to 27 seconds. So how you will find? First, we'll see how many minutes it take to cool it down. So 23 minutes in the end time, end watch says 23 minutes, and the start one says 11. So 23 minus 11 will be 12. So time minute is 12 minute, and we should not ignore the second also. So now we'll find the second. 27 second minus 19, which will give you 27 minus 19 is 8 second. So 12 minute and 8 second, which is D1. Okay, so now why we have separated this minute and second, we should always do it separately, so that if there is more than 60 second, we have to add that 60 second into the minute. So it's always better to calculate the minute and second separately. So if there is more than 60 second, we can add it to the minute to get the exact answer. Okay, so next question is, it says, okay, let's start with the next one. I wish to roast a chicken for Sunday lunch. The chicken requires 1 hour and 20 minutes in the oven to be properly cooked. The oven must be switched on 10 minutes before any food is put in order to preheat and reach the correct temperature for cooking. I wish the chicken to be ready at 4:30 p.m. What time must I switch the oven on? Okay. So let us see all together how much time it requires. It says that chicken take time to cook is 1 hour. The cooking time of the chicken is 1 hour and 20 minutes. And for nearly about 10 minutes it's take for the oven to preheat. So 1 hour 20 minutes, 1 hour and 20 minutes for cooking is the cooking time, whereas adding 10 minutes for oven to preheat, the total time it will take for the chicken to be ready is 1 hour 30 minutes. So if she wants her chicken to be ready by 4:30, she has to start with 1 hour 30 minutes before. That means she has to start at 3 p.m. Okay, so next one. Question next. A particularly diligent student wants to measure the volume of some liquid for an experiment. She has two measuring cylinders available, a large 250 ml one and small 50 ml one. The liquid will fit into either of the two measuring cylinder. Okay, so the liquid that she has, it can fit in both. As expected, the liquid forms a meniscus where it touches the side of either measuring cylinder. Which cylinder should the student use to get the most accurate result, and from where should she measure the liquid level? Now, this question we have already discussed, that whenever we take a reading of a liquid in the measuring cylinder or any of the liquid, we always take the reading from the lower meniscus, right? We take the reading from the lower meniscus. So top meniscus, this two options is opt out. We have to take the reading from the lower meniscus. The correct way of taking reading is, that means it can be B or D. Now B says the measuring cylinder is large. Again, we have discussed before that large measuring cylinder will give less, the height difference will be like, there will be no height difference. And if you will use small measuring cylinder, the height difference is quite sharp, and it make it easy for you to take accurate reading. So for this one, from B and D, D1 is correct, that she should take the small measuring cylinder and from the bottom of the meniscus. Okay, a geologist want to measure the volume of particularly interestingly pebble she has found in a river. She uses the apparatus shown below. So whenever we need to find volume of irregular object, we use this method. So what we do, we take a measuring cylinder. First find out, mark the level of water before putting your irregular object like your pebble, and then mark the water level after putting your irregular object, and then subtract. So she's using the exact same method to find out volume of irregular object. So here it is pebble. So as you can see, before putting the pebble, the height is around 5. We see the lower one, so which is 5, and after putting the pebble, the height is around 15, 16, 17. Okay, so it is 17. So 17 minus 5, which will give you, no sorry, 17 minus 6, it is 6, right? This is 5 and one level up it will be 6, so 17 minus 6 will be 11. So we have 11 as option 1. Okay, so next one it says that which of the diagram below correctly shows two forces, W and X with their resultant. Okay, so whenever we find out resultant force, we follow this tip to tail method. Tip to tail means, as you can see, this vector W, this arrow is heading, so this will be tail, and from where it is coming, this will be tip. So this is tail and this is tip, and resultant vector come we get the resultant vector of two vectors by joining their tip to tail. As you can see, the first one, this is the tail of vector W, and this is also the tail of vector W, and resultant vectors are coming by joining tail to tail, so this is wrong. Now come to this one. As you can see, the arrow is heading towards this side, so this will become tail of this one, and for this one also this is tail. That means tip of both the vector is this one and resultant vector is coming from this one. Again, this is also wrong. Now look at the third one. uh, Arrow is heading towards this side, so this is the tail of x vector, and this is the tail of x vector. So you can see again we're getting the resultant vector by joining tail to tail. This is also wrong. Now come to this one, last one, which says that see, this arrow is heading towards this side. This is the tail of vector W, and for this is the tail for vector x. It means this is the tip of vector W, and the resultant vector we are getting by joining tip to tail. Hence this is the correct one.